Hi, alright, this is the video for lab 7. This is the circuit for part A. Current flows in from positive 5 volts, goes through this diode right here, and then flows out back to ground through this resistor. We can measure the current across this resistor and the voltage across this resistor and the current through this circuit, and do a plot of the voltage versus the current, and we get a chart that looks something like this. Very low voltages across the diode, there is no current flowing through, but once the voltage crosses a certain threshold, the current is allowed to flow through the diode. This is the circuit for part B. The only difference is that in addition to voltage going to ground through this resistor, we also have voltage going to ground through this capacitor. And so that allows this circuit to charge and discharge. And so what we see when we look at the waveforms for this is there is this, in blue you can see the voltage across the diode, and you can see that there is a ripple voltage, that the voltage will hover around this base voltage here, but it will dip up and below. So this is the way that we can turn this AC signal here into what's pretty much a DC signal. When we take out the capacitor, we see just a normal rectified curve. And using the cursor function, we can actually measure what this ripple voltage is. Okay, this is the last circuit for part C. The positive input to this op-amp is the wave from WaveGen. The negative input comes from this resistor, which is connected to ground, and from this diode, which feeds back from the positive, or from the output back into the negative. So when we try different frequencies and amplitudes for the input, we get various functions. You can notice that on this one there is a very noticeable slew rate, and so we can see the distortion on this signal, and this slew rate can actually be measured using the cursor functions again.